Okay, we're back again. Here is numbers 8 through 13. We're first talking about lines, writing equations of these lines. So remember, the one that we need is the slope. So we first need to find the slope. And the slope is the y term minus the y term. So 5 minus 1 over x minus x. 7 minus 5. Okay, so notice I went from the right point to the left point. I have to do that in both cases if I'm going to get the correct slope. So this turns out to be positive 6 over 2, which has a slope of 3. Okay, so I'm going to write this in what's called a point slope form. So that is y minus, we're going to go with this one. So this is y minus 5 equals the slope 3 times x minus 7. Okay, this is the most popular one for calculus. And you don't have to do anything after that. Okay, or we could use the other point, y minus negative 1, which is y plus 1, equals 3 times x minus 5. Both of those equations give you the same line. Okay, they're just using two different points. So likewise here, perpendicular to this line, sometimes we call this normal in class. The normal line is an engineering term. The normal line is the perpendicular line. So the slope to a positive 2 is a negative 1/2. Okay, that's your perpendicular slope. So we're going to use that same thing, the same form, and do y minus negative 1, which is y plus 1, right? We're using this point, and going into point slope form equals the slope, which is negative 1/2 times x minus 4. Okay, you can leave it just like that, unless it wants you to write it in y-intercept. But this one is just fine to do. Okay, and now we have this other stuff down here. We have 4 functions. Okay, this is a composition. Remember, this one is a composition. So we're going to take the g equation and plug it into the f. So we're going to take 3x plus 6 and plug that into the x value in your f equation. So 2 times this minus 1. And this happens to be 3x plus 6. That's a 6. Okay, you would multiply that all out and it would be all good, and we would get something like 6x plus 12 minus 1 is 6x plus 11. Okay, likewise over here, we're going to plug the f function into the h. So we're going to take this f and we're going to plug it into both of these places in your h function. Okay, both of them. So we have 2x minus 1 squared minus 2x minus 1. Okay, so if we multiply this all out, we get a 4x squared minus 4x plus 1. Okay, and then minus 2x plus 1. So the answer would be, where do I have space? I'm running out of space. 4x squared minus 6x. 4x squared minus 6x, that was what it would be. So let's write it up here. 4x squared minus 6x, because the ones cancel each other out. Okay, so this one goes here. Wow, there's a lot of lines. Okay, G inverse. If you're going to do G inverse, that means you switch the x's and the y's. So 3y plus 6. And then you solve this equation for y again. Remember, finding an inverse, we switch them around. So we'll subtract the 6 equals 3y, and then we'll divide everything by 3. So one way we could do that is to write the 1/3 out front as a multiplier rather than as a divisor, equals y inverse. Okay, and the last part is to put this notation, this y inverse business in there, so that we know that for sure it is an inverse of this function for g. And the last one is to invert this one, 2x root 2x plus 5. So we're going to put the x out here, and the y goes underneath your radical, 2y plus 5. Okay, so the first thing I'm going to do is square both sides to get rid of this radical. So x squared equals 2y plus 5. Now if I undo all of my stuff, I'm going to subtract the 5 and then divide by 2. So my total answer, and I'm sorry I'm running out of space here, 1/2 of x squared minus 5 is going to be the inverse for your A term. A inverse. Okay, so there are some writing equations of lines and a little bit of composition and inverse finding.